Toothpaste is necessary for our daily life. During last two chapters, we have comprehensively investigated the composition and main rheological properties of toothpaste, which is of great importance to manufacturing and using. Toothpastes are mainly composed of abrasives, surfactants, therapeutic ingredients, flavors, and other active agents in a background liquid of humectants and water. These compositions contribute to different functions and characteristics of toothpaste. We have mentioned the ingredients of toothpaste in our first video, including abrasives, sodium lauryl sulfate, carboxymethylcellulose, glycerol, carrageenan, copolymer, sorbitol, and water, flavors, and color solution. By putting all these functional ingredients together, look, we got a perfect toothpaste. Now we have known the main ingredients and their function, but what will happen if the composition of toothpaste is changed? To learn more about this, we set a simple experiment. We transfer the same volume of toothpaste to two empty vials and add the same amount of water to dilute them. We shake both vials for about 3 minutes. Dilution reduces the viscoelasticity of toothpaste dramatically. After shaking, there are a lot of bubbles trapped in the diluted toothpaste. Then we add salt to the sample on the right side. Shake and mix again. Most of the bubbles disappear immediately after shaking, and only a little bubble exists in the upper surface. This is the ultrasonic bath. We put the two vials in it and kept 30 seconds. After this, most bubbles rise to the surface, but still a lot of bubbles. Then we keep the two vials still on the desk for more than 1 hour. We can see some sediment in the bottom in both two vials. The difference are for the no salt vial, a lot of bubbles are still there, but for the salt added vial, no bubbles exist. This experiment proves the function of sodium lauryl sulfate. SLS is used for its ability to create a foam and for its surfactant properties. The added salt affects the foaming ability of surfactant in toothpaste because of the charge. In industrial processing, it can be indicated that addition of salt or ionic compound may influence the effectiveness of surfactants. Toothpaste is normally referred as Bingham plastic fluid. Bingham plastic is a viscoplastic material that behaves as a rigid body at low stresses but flows as a viscous fluid at high stresses. It flows only if submitted to a stress above critical value, otherwise it behaves as a solid body. The fluid of toothpaste obeying the model as the figure shows. Plastic viscosity is the slope of the line and yield point is the threshold stress. It presents a linear behavior between shear stress and shear rate after putting on an initial force. In this test, we used two packed toothpastes. One toothpaste with original package did not squeeze, but it was not falling down from bottom in short time, while the toothpaste with original package fell down easily with squeeze. Additionally, toothpaste is a shear thinning fluid. In rheology, shear thinning is the non-Newtonian behavior of fluids whose viscosity decreases under shear strain. It's generally not seen in pure liquids with low molecular mass, but in a high molecular polymer. It is considered to be the result of microscale structural arrangement within the fluid, or the organization of microspheres into horizontally packed structures that slide over each other more easily. Now let's go more deeply into the microfactors associated with the rheological properties of toothpaste. According to the literature, the microstructure of toothpaste has abundant cross-linked mesh networks due to the presence of polyethylene glycol and carboxyl methyl cellulose sodium in their formation. Generally, the size of the abrasive particles should be smaller than that of the mesh, which helps to form a desirable microstructure with crowded and jammed abrasive substances within the network. Toothpaste with oversized particles may exhibit much sparse networks. Overall, in this project, we researched the main rheological properties of the toothpaste and how they connect with the ingredients. The investigation and experiments showed that there are many important factors should be taken into account when building a toothpaste. In a word, toothpaste is a typical complex fluid and is not that simple as it looks like. The rheological study of toothpaste are very important and necessary for both manufacture and research. Enjoy your toothpaste and thanks for watching.